Okay, so our last speaker is Piero Scaruffi. As you guys know, probably, he's a cultural historian who's lectured in 3 continents. Oops, I lost that. Can't see it anymore. Piero, I'll let you introduce yourself.
No, I don't introduce myself. I just start. We're running out of time.
Just start. Yep.
Okay, so this is not what you think it is. The title is a little misleading, but there's a reason. So so ChatGPT is based on something, an architecture called transformer, and I think it's a new computing architecture that could replace or at least coexist with the traditional von Neumann architecture of our computers. All the computers from the big ones to your smartphone are von Neumann architecture right now, and you program the computer. With the transformer-based architecture, you don't program the computer, you train it. So this has been discussed for a few years. In particular, Andrei Karpathy talked about software 2.0, a new way to tell computers what they have to do. I will not spend much time on this. The funny thing is that this came out of studying language, natural language processing, and we can credit back Firth or even Wittgenstein with the idea that the meaning of a word depends on the other words in the sentence. Fast forward to 2017, and Google introduced this architecture called the transformer, which was originally invented for machine translation and uses this attention mechanism that I'm not going to explain, but basically does that, relates a word to the other words in the sentence. So on the left of this slide, you see the famous paper, "Attention is all you need." It turns out it is not all you need, because you can see in the middle of the diagram of the transformer is way more complicated. But yes, the key thing is the attention, and that equation that you see down there with the softmax operator is becoming famous. That paper is already one of the most cited papers in computer science, and this equation, you will see it very often. Now, the transformer, again, was invented for machine translation. And what it does, at the end of the day, it predicts the next word in a sentence. You train a transformer-based architecture on a large data set of text, a large body of text, and the transformer-based system learns to predict the next word in a sentence. Ultimately, that's all it does. So the one moment is when, and I'm not sure that the authors of that paper realized it at the time, that the transformer is actually general purpose architecture. It can analyze any kind of sequence. So GPT-3 is probably the most famous right now that generates text. But you already have DALL-E, Stable Diffusion, Midjourney, and so on that generate images. And then you have other kind of transformer-based systems. They generate other kind of things like software code. So somebody came up with the term foundation model, not just language models. So language models are a specific case when the system is trained on text, but you can have transformer-based systems on in other domains. You just as long as you have a data set in a domain, you train the transformer-based system on that data set, and you get a foundation model. And so quickly, we have foundation models. Before I get to the language models, let me tell you, there are other foundation models. For example, for writing software, somebody predicted in 5 years, the majority of software code will be written by AI. In chemistry, for climate, for finance, for law, well, healthcare is coming. They're working on it. So as long as you have a data set, you can create a foundation model based on the transformer technology. That's why I called it a general purpose computing architecture. So one case of foundation model is the language model. The language model, again, based on the transformer and trained on a data set of words. I'll keep emphasizing, it's designed to predict the next word in the sequence or the missing word in the sequence. There's two major categories. It is not designed to store or retrieve data. It is not designed to be an encyclopedia. It is about predicting the next word in a sentence. GPT-3 is the most famous right now. Mentioned briefly, it's not just one transformer. There's a lot of complexity there. 175 billion parameters. What's a parameter? Think of the connections between neurons in your brain. And ChatGPT is simply the user interface to talk to GPT-3, to this language model. So, and now there's a race to develop language models, especially the big three technology powerhouses, Google, Microsoft, and Meta, getting bigger and bigger language models. As you know, ChatGPT is prone to hallucinations. It's relatively easy to create those if you ask questions about obscure things. For example, I prompted the ChatGPT with this obscure, silent, black and white movie of a century ago. And ChatGPT, sure enough, gave me a very detailed description of the movie. Unfortunately, it's completely wrong. And then there's a famous novel in Italy, La Luna e Falò, but it is not made by Raponi. Raponi is a friend of mine. And sure enough, ChatGPT decided that there is a movie made based on this novel. It tells me that filmmaker really existed, but never made such a movie. And ChatGPT calls it a beloved classic of Italian cinema, but it never existed. So I asked it to write a summary of my novel, The Trial. As you know, The Trial is a masterpiece by Kafka. And it turns out I am the author of a psychological thriller and about a man named Mario, and then more or less this mimics Kafka's novel. ChatGPT also tends to repeat things. It learns from us. It learns from our text. For example, I ask who discovered graphene, and as sure enough, it tells me that these two Russian Nobel Prize winners discovered it. They did not discover it, no matter how many times this is repeated on the web. It was discovered way before. They got a Nobel Prize for a different reason. This has been fixed now, but when GPT-4 came out, a user asked, how can I kill the most people with only $1? And sure enough, the language model gave detailed instructions on how to do that. And so, as you probably know, some people a few days ago asked to stop development of these systems. Some other people disagree. I will not get into that debate. Now, so my talk, that was just the 5-minute introduction to what it is. So about jobs, if you are wondering which jobs will become, if your job will become obsolete, OpenAI itself has published an interesting report where it shows which skills overlap with the skills of a language model. So you can read for yourself. I found this report more interesting from the University of Pennsylvania that shows the jobs that probably will not be automated, not at least by this technology, are low-level manual jobs, things like plumbers, waiters, construction workers, and so on. And the countries least affected will be the underdeveloped countries. That's why I titled this The Revenge of the Poor. I entered Revenge of the Poor in one of these generative models and got the illustration that you see on the right. So programming and writing skills are more susceptible to being replaced by this technology than those without formal educational credentials, which I find interesting. And of course, the real question is which jobs will be created. And a couple of weeks ago, Anthropic, which is a popular AI startup, posted this job, a prompt engineer and librarian, and you can see the salary is not bad. Now, applications of this, I want to discuss applications of this technology, in particular to the humanities. But let's start with the inspiration that comes from artists and writers. There's already people writing books with this technology, and most of them are really bad, so don't read them. But it tells you that this can be a tool that can help proofread and ghostwrite, and you know, many more people will be able to publish books. I entered Great Writer in one of these generative models, and I got that illustration. In the previous laser, Javier Ideami talked about the film that he has made using pretty much only generative models. So that's also becoming easier. You will be able to enter the text, the plot of your movie, and generate the movie. Applications to education, my opinion, difficult to foresee right now. Maybe a trend towards oral examination instead of written essays, which, by the way, is the way school was when I was studying in Italy. But generative models can also be used to create tutors, let's say on relativity. Create a model that you can interact with at home to learn more about relativity. Or if the data set is all the books written on Julius Caesar, you can create a clone of Julius Caesar and then have a conversation with Julius Caesar about what he did and his view of the world. We can get inspiration also from an artist and programmer called Giacomo Micheli, who has this funny website, The Infinite Conversation. I haven't tried it now, I hope it's still on, where two intellectuals, the intellectuals really exist, I assume he somehow cloned them, are having this conversation 24 hours a day, 7 days a week. That's an interesting idea. And you can go on, you can go beyond that. You could create a generative model for a book. Instead of reading the book, you could talk with the book. And if this sounds science fiction, it's actually, this is a screenshot of somebody who is doing it right now, probably not the only one. So you will be able to ask questions instead of reading the book. You could create scholars in various disciplines. These are all illustrations generated by generative models. I just gave the description and it gives me cute illustrations. Generative model in a specific discipline, and this generative model behaves like an expert, a scholar in that discipline. Or you can take all the books written by an author, for example, Balzac, who wrote many novels about French society at his time, and then be able to converse with Balzac about his view of the world. You could maybe train a generative model on with all the books published in a certain era, and be able to converse about the view of the world of that era. And I mean, this is not this is more a funny application, but if you keep track, if you have a diary and you keep track of all your social media posts, of all your emails, you could train a generative model to behave like you. You could converse with yourself. Anyway, these are ideas for the humanities. Now, what is it really this ChatGPT. In my opinion, and why I said it works so well, it actually, I showed you that it doesn't work well. Well, it turns out we don't work well. So I see ChatGPT also as a mirror. They are behaving like humans, actually. And we have this idealized way of humans as extremely intelligent and creative. Yeah, well, true, we are creative, but we are also unreliable. We repeat things that other people told us, and very often distorting them. And we have biases. So when these language models displayed biases, the racist or sexist or whatever, unfortunately, that's what we are. We humans have biases. So I see ChatGPT as an observer of human society. And it has this naive honesty to tell us, to talk about our beliefs, our biases, our dogmas, our weaknesses. And so what is it? We are not interactive. We're not interacting with one thing. We always think of AI as one entity, but these generative models really represent not one person. They represent all the people who ever posted something on the internet. There's plumbers, bloggers, news media, software engineers, and yes, racist, criminals, and so on. We're really, when we talk with ChatGPT, we are really talking with ourselves, our society, the human race. That's why I subtitle it. ChatGPT works so well. It works so well in behaving like us. Some people are talking about the fact that the mind is less special than we thought, because these chatbots are beginning to really look like humans. So it turns out that emulating the human mind was not so difficult after all. Whether you agree with this or not, of course, it's a long discussion. But the point is, maybe we're approaching a Copernican revolution when we find out that the mind is not such a special thing after all. It turns out what is special is the body, because progress in robotics has not been that great. And and we don't have actually robots that can mimic the human body, I don't know, grasping, throwing things, playing soccer, as well as humans do. I used Michelangelo's David, of course, as an example of a human body. Down there, I'm aware of robots like Boston Dynamics. I was playing with it just a couple of days ago. So, well, I don't know, for a philosopher, this could be an interesting discussion. Maybe the body is more unique than the brain for humanity. The human brain has a body, by the way, so even thinking of it, the mind, a mind without a body is missing something. If you've seen the watch, every AI presentation I learn must have at least one picture from a Hollywood movie. So Ex Machina, if you've seen the movie, the reason we cannot have an Ex Machina even with the chatbots is that Ex Machina has a body. And of course, the moment you say something these days, you have to be careful, but there's already somebody doing it. So I know of at least one project where they're trying to do just this, integrating the language model with a robot. And if you want to know more about what I think about chatbots, go to my YouTube channels, and you'll find 3 long videos that talk more about the technology and a little more about philosophy. And I thank Stable Diffusion, DALL-E, and ChatGPT, the generative models I've used for this presentation. Thank you.
Thank you. That's very interesting and provocative.